database. Hi everybody, I'm Beth Sheets. I'm a product manager in the data sciences platform of the Broad Institute. I contribute to Terra, so if you have questions about Terra, ask me. And I'm also happy to share that the All of Us and AnVIL Imputation service is now available for you all to try to use. You can learn more about it and figure out how to get started at the link provided at the bottom. So I know we have a diverse audience, so I'm just going to kind of explain what imputation is. So for folks like Elise and Manning who are doing population studies for Q-loss or polygenic risk scores, there's often a trade-off researchers have to make due to their budgets where they need to increase the number of samples to gain statistical significance. And to do that, they have to trade off how much depth they have per sample. And they do that by either using array genotyping or low-pass whole genome sequencing compared to 30x whole genome sequencing, which are much less expensive but provide less information per sample. So imputation is a computational process that can fill in the missing data for those samples. And it does that by comparing the data you submit to a large reference panel. And the accuracy of the imputation or the imputed data that you receive really depends on the size and diversity of the reference panel. And we know that non-Europeans are still heavily neglected in genomics research. I borrowed these two figures from GWAS-DiversityMonitor.com, and you can just see how dominant European ancestry is in our genomics research for our clinical care. So this is a problem because genetic insights derived only from European or primarily from European populations are not portable to other ancestries. This leads to inaccurate disease risk prevention, undetected genetic variants, incorrect diagnoses, ineffective treatments, and this can all exacerbate health disparities. And it just leads to an incomplete understanding of human genetics and disease. So to try to help solve this problem that we're seeing in the field, we have built the largest, most diverse reference panel in the world to use with our imputation service. And that's thanks to the All of Us program and the AnVIL Center for Common Genomics for allowing us to combine data from these two biobanks in this way. So our reference panel is over 550,000 samples. 250,000 of those are from non-European inferred genetic ancestries. So in the bar charts, you can see the total size of our reference panel in purple, and then green is just non-European ancestries, and then after that are all of the other imputation panels available in the field. So we're launching a service that allows researchers to leverage this resource without giving direct access to the panel itself, and that's to protect the privacy of those individuals that contributed their data. So this is just a deeper dive into what the panel looks like. You can see the different ancestries that are available in the reference panel. And so we see that we have a lot more data. We wanted to test if we actually get greater accuracy. So this is a preliminary scientific validation experiment that we did. Arthur's in the room with us, and he can also help answer questions about this early study. So we had about 48 samples that we knew were absent from both the All of Us and AnVIL reference panel and the TopMed reference panel, which is the next best in field reference panel available. And for these 48 samples, we had both their global array data as well as their 30x whole genome sequencing data. So that allowed us to have the truth information from the 30x whole genome sequences. And so we imputed that array data in both of these imputation services. And you can see the breakdown of the 48 samples below. We were able to have representation from different inferred genetic ancestries. So again, these are small sample sizes. So hopefully more studies will come out where we can learn more about how these two panels compare. So from this study of 48 samples, we do see higher accuracy in imputed variants and indels across ancestries. So on the left, those 6 charts are imputed SNPs, and on the right, it's the same but for indels. It's broken down into 6 different genetic ancestries, and the red is the R squared, so that's comparing the imputed variants from the reference panel, from being imputed in the in the All of Us reference panel, sorry about that, compared to its 30x whole genome truth. And then the blue is the same results from using the TopMed server. So you can see that the All of Us and AnVIL reference panel gives higher accuracy in all of these ancestries compared to top med, with one exception, and that's in that top left box, which is looking at African ancestry. And this is somewhat expected, we believe. So again, it'd be interesting to look into this further with more data. But the top med panel includes samples from sub-Saharan Africa, whereas all of us at AnVIL reference panel is based on Americans. So how does the service work? It's pretty simple. All you have to do is submit your samples to our service. We use a quota system to manage costs. So we check if you have enough quota to impute the number of samples we've submitted in your multi-sample DCF file. We perform CPC on your inputs, and then we phase and impute the samples against the protected reference panel. And I'll point out we also phase against that large reference panel, so it's hopefully giving you better statistical phasing as well. Once your results are ready, we'll email you, and you'll have 2 weeks to download your results to it. If you want to get started today, we currently support array data that has been aligned to H238 that's hosted locally. All users will receive 2,500 quota during this beta period thanks to support from the NIH. And you will submit and monitor jobs using a command line tool. So we have a link to our documentation there below that can help you get started with the command line tool. It uses Python, so if you're familiar with Python, you can get started there. In our roadmap, we're planning to do a lot of usability improvements. We're getting a lot of user feedback since we went live, which is really helpful in helping us prioritize what's most important to the community. Very soon, we're going to release a point-and-click user interface, so it's easier for everyone to use. We'll also provide support for cloud-hosted data, because we know a lot of you like hosts that are already working in the cloud and don't want to download their data, re-upload it. And what else is really exciting is that we'll roll out some pipelines that support imputation of low-pass genome data. This includes both the blended genome exome product from the Broad Clinical Labs, as well as something like 1.5 exome. We're also going to roll out a user payment system to better support these higher cost imputation pipelines like the low-pass genome data, but also much larger sample sizes that folks want to run for service. And with that, I just want to acknowledge the team at the Data Sciences platform that helped create this resource for the community, and our collaborators like Arthur in the room who helped us create this reference panel, and our funders and collaborators at the All of Us program at HGRI that allowed us to create this resource for the community and give us lots of great feedback along the way, as well as the Broad Institute. So thanks. I can take questions.
Any questions? I have one. Could you comment on the runtime? Comment on the runtime to run, I don't know, a few samples or 1,000 samples?
Yeah. So we benchmarked with the quota that we make available to the community for 500 samples, and you'll get your results the next day. And there's no queuing. So we really expect, because it's a cloud-based resource, to get you your results fast, even for much larger data sets than that.
Is this a platform that is fairly friendly to non-bioinformaticians, or how fancy do we need to be?
I would say in maybe a couple of weeks, you don't have to be very fancy at all. It will be a quick button user interface, so you just have to drag your samples off of your local computer into the UI, hit run, and hit download.
Great. Any last questions? Okay, let's thank Beth again.